All right, so I think this is recording. Let's take a look at this problem. They're asking us to simplify 6 times the square root of 192 times u squared times v to the third power. Now, when we have multiplication underneath this radical, you can break apart multiplication. So we can look at this and break it down to something that's easier to look at. The square root of 192, the square root of u squared, the square root of v to the third power. So off to the side, we want to work with 192. Now, when we break down 192, I know it's divisible by 2. But what would make my factor tree shorter if I can find the largest perfect square that divides 192. So what are the perfect squares? Well, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, and 10 squared is 100, and we could keep doing that all day if you want. But let's look and see which of these numbers divides 192. Now, I'm pretty sure 4 will. If I have 192 divided by 4, yes. But the thing is there a bigger number in this list? See, what I'm trying to show you here is a way to make our factor tree shorter and not just so big so that people have so many factors to deal with. So 192 is not divisible by 9 because I get a decimal number on my calculator. 192 divided by 16. Yes, 16 times 12 is 192. So it's going to result in a shorter factor tree if I write 16 times 12. But maybe I can even make it shorter than that. Let's keep going. It's not divisible by 25. 192 divided by 25 is a decimal number. And I've got a calculator right now. You can't see that I'm just not. I definitely use a calculator like a tool. When I divide it by 36, I get a decimal number. When I divide it by 49, I get a decimal number. But hey, when I divide it by 64, 192 divided by 64, I've got 64 times 3. And like I say, what's the advantage of doing that? That 64 breaks down to 8 times 8. So we can very quickly see that the square root of 192 is equal to, well, 8 times 8 times 3. And since we have a group here, we can split that apart and say take the square root of 8 times 8 times the square root of 3. Well, 8 times 8 is 64. Hey, the square root of 64 is 8. Whenever you have a pair, that pair, you just write it as a single factor. So what this allows us to do is to come over and say, I'm going to replace the square root of 192 with 8 times the square root of 3. And like I say, it might help people out a little bit if your factor trees are not so huge, not so big, and if you try to find the largest perfect square that divides that number, it might help out a little bit. Something to think about. You're going to get the same final answer that we do, even if you do have this huge tree. All right, so I'm going to erase this work. I'm going to leave my squares up there. Well, no, I don't need any more because I don't have any more numbers. All right, u squared. Boy, that's easy because you have a pair of u's. U times u is u squared. So the square root of u squared is just u. This is u because you have a pair, u times u. Now what about the v? How can we simplify this? Well, pretty easily. We've got v cubed, and we know what v raised to the third. An exponent is just a way that implies repeated multiplication. v to the third power means v times v times v. And we've got a pair right here. So this v to the third power, we're able, when we have multiplication, to split this into two radicals. And we can simplify that first one because you have a pair. This is v. Now, I don't have a pair of v's right here, so this stays the square root of v. All right, so we come back here and we say, well, we can replace the square root of v to the third power with v times the square root of v. Doesn't look any simpler. You know, the directions say to simplify, and this looks like kind of a big ugly mess. But look at what we can do. Since this is all multiplication, we can multiply in any order that we want. Let's multiply the numbers together that are outside of the radical. 6 times 8 is 48. And let's multiply the letters that are not underneath the radical. U times v. And now, everything that is underneath a radical, we can place it underneath a single radical. Square root of 3 times the square root of v. If you have the square root of 3 times the square root of v, that's the square root of 3v. So now this is what they refer to as in simplified form. So it doesn't look like it, but this original product here, this original expression is equivalent to what we just figured out, 48 times u times v times the square root of 3v. So I hope that helps, and I'll talk to you later. Bye.